This video is our factoring test review. It is good for the co-requisite 4-day-a-week class and the 2-day-a-week class. And here we go. It is the factoring test and review, so it is very similar to what you're going to get in a test, just all different questions. So I'm going to go through and identify each type as we go along. Number one here is a two-term phrase. I don't see anything in common all the way across, so I notice that it is a difference of two perfect squares. How? The x is squared, so that's the only thing it can be. I've got the difference in the base being squared here is a 4, the base being squared in the second position is an x. So I open up my two parentheses factors. The first base goes in the first position, the second base goes in the second position with a plus and a minus between them. You can't just rewrite it as x squared minus 16. That would be wrong. That is a different problem entirely. Now, in our second example here, that is a greatest common factor problem. There are only two pieces there, and it looks like it was before, the step before could have been a factoring by grouping. But since they're giving it to us at this point, all we need to know is that they have a y plus 3 in common all the way across. So we're going to open up our leftover parentheses. When you factor the y plus 3 out of the first term, you're left with a y. When you factor the y plus 3 out of the second term, you're left with a plus 7. Done. The next one is a type 2 trinomial. So I noticed they don't have anything in common that I can factor. It's a type 2 because it does have a 5 out in front of our squared term. So I'm going to multiply the 5 and the 5 together, which is 25. Factors of 25 are 1 and 25 and 5 and 5. If I'm trying to make them add up to a negative 26, I'm going to make the negative 1 and the negative 25 both negative. The 1 and the 25 both negative. They add up to be negative 26, but they still multiply out to be 25. So now I'm going to rewrite it. Remember, type 2s, we actually go to a grouping format. So bring down the 5x squared. I'm going to rewrite the negative 26x using those two numbers. Minus x minus 25x plus 5. Now we group. When I look at the first group, they both have an x in common. When I factor it out, I'm left with a 5x minus 1. Now I'll bring down the negative between the two groups. 25x and 5 both have a 5 in common. When I factor the negative 5 out of the first term, it leaves behind a 5x. When I factor the negative 5 out of the second term, it leaves behind a negative 1. Now I'm down to two pieces. Those two pieces have a greatest common factor of 5x minus 1. I'm going to open up a leftover parentheses. When I factor the 5x minus 1 out of the first term, it leaves behind an x. When I factor the 5x minus 1 out of the second term, it leaves behind a negative 5. Remember, all of these problems are checkable, and feel free to pause the video at any point and try to work them yourself. Number 4, the next one is a 4-term phrase. I don't see anything in common all the way across, so I'm going to go ahead and group. The first two pieces have a squared term in common. When I factor it out of the first term, it's going to leave behind an x. When I factor it out of the second term, it's going to leave behind a plus 2. Now bring the negative down between the two groups. 9x and 18 both have a 9 in common. So I'm going to factor it out. When I factor the negative 9 out of the first term, it's going to leave behind an x. When I factor the negative 9 out of the negative 18, it's going to leave behind a plus 2. Now we're down to two pieces. Those two pieces have an x plus 2 in common, so I'm going to open up my leftover parentheses. When I factor the x plus 2 out of the first term, it's going to leave behind an x squared. When I factor the x plus 2 out of the second term, it's going to leave behind a minus 9. Now, step 3 in our factoring strategy is that you should always look at your final factors to see if they factor further. This second parentheses is a difference of two perfect squares. The number being squared in the first position is an x, the number being squared in the second position is a 3, and it's a difference. So that actually can be broken down a little bit further. The first base goes in the first positions, the second base goes in the second position, and a difference of perfect squares has a plus and a minus between them. Now the x plus 2 that had already been factored out, that's part of our final answer. Let's look at number 5. That is a type 1 trinomial. Get to where you recognize them. This one has a 1 out in front of the squared term. So I'm going to take the constant, negative 10, and find his factors. 1 and 10 and 2 and 5. I need to find the pair of factors that can build a negative 3x out of. That I can build a negative 3x out of. The 2 and the 5. I'll make the 2 positive, the 5 negative. I can make a negative 3x out of that. So, oh, sorry. Let me erase that. Negative 3x. Okay, now that means since it's a type 1, you just open up your 2 parentheses. Factors of x squared are x and x. Factors of negative 10 that we found were positive 2 and negative 5. Remember, all factoring problems are checkable, so feel free to do so. On number 6, 6, 13, and 28 don't have anything in common all the way across. So I'm going to go ahead and multiply those two together. 168. And I'm going to write all the factors of it out. Because it's a type 2, remember, it's going to go to that factoring by grouping method. Let me see. Let's see. I think I'm going to use, and again, you can list them out. I'm not going to take time to do that because I want to finish the video. But I'm going to use factors 8 and 21. They multiply out to be 168, and I can get them to add up to negative 13 by making the 8 positive and the 21 negative. Let's rewrite it. That is 6x squared. Instead of negative 13x, I'm going to rewrite it using those numbers. Plus 8x minus 21x minus 28. Now I'm going to group the first two together and the second two together. This is how we do type 2s. All right, now the 6x squared and the 8x both have a 2x in common. So I'm going to open up a leftover parentheses. That's going to leave behind a 3x plus 4. I'm going to bring down the negative. 21x and 28 both have a 7 in common all the way across. When I factor it out, I'm left with a 3x plus 4. Now we're down to 2 pieces. If I factor the 3x plus 4 out of both pieces, it's going to leave me behind a 2x and a minus 7. Oops, and that was it. All right. The next one is a 2-term phrase, and it happens to be a difference of 2 perfect squares. The number being squared in the first position is a p. The number being squared in the second is a 5. I'm going to go ahead and open up my 2 parentheses factors. Remember, perfect squares, 2 by 2. I'm going to put the first base in the first position, the second base in the second position, with a plus and a minus between them. And now this next one, this is also a type 1 trinomial. It's got a 1 in front of the p squared. So I'm going to go ahead and open up my 2 parentheses. This one has something else that's kind of interesting. Now, the p squared I know has factors of p, and they go on the first term. I know that the factors of 24 are going to go at the end, but there's also a q squared. Don't overthink it. The p squared at the beginning gave me a factor of p on my first term. The q squared at the end is going to give me a factor of q at the end of each term. But I still got to do the 24. Factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. The ones that'll give me a negative 11 PQ will be 3 and 8. I'm going to make them both negative. They will add up to negative 3 PQ. I'm sorry, negative 11. Wow. Okay, negative 11 PQ. And all I have to do is make that a negative 3Q and a negative 8Q. And again, if you don't trust it, check your work on that one. I want to do one more and then we'll go to the next video, just not to make it real long. All right, I'm looking at this next one. It's a 2-term phrase, definitely not a perfect square problem though. Let me get rid of that. So first thing I'm going to do is identify what's being cubed, or if they have anything in common all the way across. No greatest common factor, but then I notice this is a 5 that was cubed, and that is a y that was cubed. This is a 2 that was cubed. Cubes factor into a 2-term and a 3-term phrase. Now, with the 2-term phrase, it's the two bases with the same sign as in the original problem. The trinomial we're going to build. The first base squared goes in the first position. 5y times 5y is 25y squared. The last term is the second base squared. 2 times 2 is 4. The middle term is the first base times the second base, 10y. This is always a plus, and this sign is the opposite of that one, so it will be negative. I'll see you in the next video.